For example, one above, which was the one about the coin at the top. For the one about the coin, find the probability that if I flip a coin 10 times, I get exactly 5 tails. We would expect 5 tails, but we want to know the probability that I get exactly 5 tails. What am I being asked? Find the probability of what? All right. 5 tails? That's what they're asking. What's the x in this case? 5. The x is the hardest part. The x always comes from your question. So they're really saying, what's the probability that x equals 5? That I'll get exactly 5 tails. We have to recognize that it's binomial. In recognizing that it's binomial, that means we should be able to find the n and find the p. This is referring to example 1. You have to flip back and read it. What was n? 10. I was flipping the coin 10 times. And p is the probability of a success. A success in this case is flipping tails. What did I hear? Somebody said something. 1/2? 0.5? Whether you guys decimals or fraction, I don't care. We agree that this is what they're asking. This is our sample size, number of trials. This is our probability of one success. So what I'm going to do, if I have this calculator, I'm going to, I'll leave it there. Binomial PDF, and in order, I'm going to put 10, comma, 1/2. I can even type it as a fraction, comma 5. If I have my calculator, I'm just going to type in the 10, and the p was 1/2. It'll turn it into a decimal for me. And 5 is my x value. Everyone okay up to here? Paste. So when I paste it, see what it, before I hit enter, see what it looks like? It looks like exactly what Kevin has to type in.
Yeah, it looks like that.
Yeah, it'll look like that. So the calculator just pastes it for me by making it a little bit more user friendly. But then once you hit enter, I get this number here. 0.246?
Yep.
Any questions on how to get to that 0.246? This is the probability, and because we had a binomial situation, we could use this to get that probability.
Okay, so it's just probability.
Yeah, it's just, and so if this problem was on the exam, it'll say, hey, I'm flipping a coin 10 times, what's the probability that I'll get exactly 5 tails? Nowhere in there will I say, hey, by the way, this is binomial, this is how you get there. It's recognizing when it's binomial and knowing this is how you get there. Calculator questions? You guys are still finding the calculators?
So for the binomial, it has to have like a yes or no.
A yes or no, or a black or a white, or a boy or a girl, yes.
So just 2 choices.
What does this mean, 0.246? The probability of getting exactly 5 tails is only about 25% chance. Wouldn't you expect that if I flipped a coin 10 times, I would get 5 tails? Aren't you pretty confident that's what I would get? Out of 10, 5 of them should be tails? Don't you think that's what would happen? Yeah?
That's in a
No?
perfect world, though, right?
In a perfect world, exactly. If I happen to get 6 or I happen to get 4, that wouldn't be real surprising. So it's hard to get exactly 5. It's only going to happen around 25% of the time. If we all sat here and flipped the coin 10 times, about a quarter of us would get exactly 5 tails. Yes, we should do that. With all the money we just won, or lost. Yes.
Does that mean that it'd be 76% to get heads?
No, it means, okay, that's a really good question. Her question was, does that mean there's a 75 or 76% chance of getting heads? No, it's a 76% chance of if I flip the coin 10 times, of getting something other than 5 tails. Maybe I get 3 tails, maybe I get 7 tails, maybe I get no tails. Anything other than exactly 5. Questions? Now, I'm going to add a question onto here before we move on. I want to know the probability of getting 3 or less tails. Probability of 3 or less. Uh-oh. Add this onto your notes, it's not in there. Probability of 3 or less tails. What is that asking for? What's X?
10.
That's N. 10 is N.
Three.
X is 3.
That's what we change, right?
Yeah, but if the problem was exactly 3 tails, then I would agree with you that X equals 3. If my question was, what's the probability of getting exactly 3 tails, then I would agree that X equals 3.
3 or less.
3 or less. So what does that mean? How many tails would I get? 3 or 2 or 1 or 0.
So we use the explanation.
3 or 2 or 1 or 0, right? That's really what I'm asking? There's some ors in here. What's the or mean? Ah, or means add. Or means add. It's either this or it's that. That's when we add the probabilities. So what do you think we'd have to do? Add what though? What are we adding? Add these numbers up? I'm sorry, what? Aha, add the probabilities. I would have to take the probability that X equals 3 plus the probability that X equals 2 plus the probability that X equals 1 plus the probability that X equals 0. Well, that doesn't sound like much fun at all. How would I get those 4 probabilities? What'd you say?
Plug them all into the.
Yeah, I would have to use my binomial PDF 4 different times. Because each one is a different X. Well, we can do that. You have to go in, you can actually pull up what you had before and just change the X value. Does everyone agree we would do binomial PDF with NP and 3? We would do 10, comma, 1/2 and 3 for that one, right? And then 10, 1/2 and 2, and 10, 1/2 and 1, and so forth.
So for the X value, can you just do like 3, comma 2, comma 1?
No, you gotta do it one at a time. But there is a shortcut which I'm about to get to. But we would have to do binomial PDF 4 different times. So we just did it over there for just the 5, right? So we would have to do it just for the 3, and we would have to get this answer. Did someone already do it? Some of you are like working ahead while I'm talking, I know that.
Yeah, so 1, 1, 1, 7, 1, 8, 7, 5.
That's for 3.
That's for 3.
That's for 3.
And then we'd have to do it again for 2, and again for 1, and again for 0. I'm gonna do those in a minute. I wanna make sure everyone knows where this came from though. I got some nods over here. Binomial PDF, NP and 3, 10,
Yeah.
1/2.
Or just do more.
You have to do them all separately. 10, 1/2 and 3, 10, 1/2 and 2, 10, 1/2 and 1. Over and over again. Everyone understand what I'm doing? I'm gonna make you do this once, then I'm gonna show you a nice shortcut. What'd you say? I'm mean? I am mean. Then you appreciate the shortcuts more. And hey, I'm not really making you do it, the calculator's doing it. So I'm gonna do the last one right now. I'm gonna do 10, 1/2, and 0. Since you guys are working on some other ones. Ooh, look at my answer for 10, 1/2, and 0. What is that? I did this one.
But that just means that there's 4 zeros.
Yeah, I have to move my decimal over 4 places, so it's 0.000976. Everyone see where that one came from?
Yeah.
I put in x equals 0 for that one. Anybody calculate the other ones for me?
Yeah.
0.0439.
What's this one?
Yeah.
0439
And then 0.0098.
0098?
Yeah.
So before we add all these, I want to make sure, number one, does everyone know where we're getting these?
Mhm.
That's a lot of nods. Anybody want to admit they don't? Okay. Say this one right here and tell me. Interpret just this number right here for me. What does it mean?
So there's like a 0.0439%.
The probability of getting exactly 2 tails out of 10 is around a 4% chance. If I flip my coin 10 times, there's around a 4% chance that I'll get exactly 2 tails. Anybody add those for us yet? We'll pick up where we're leaving off right now, but try this in the meantime. Binomial CDF with NP and 3. And compare it to that. I pick up right here when we come back next time.